In level 2, we will be finding the area and perimeter of simple composite figures with unknown side lengths. Composite figures are when you take one or more simple shapes and put them together. So these figures that we're looking at right now are a couple rectangles put together, which makes a composite figure. And we are finding the perimeter of these rectangles. So in this first example, we are missing some side lengths, and we need to add up all the sides. I know that the width of the entire figure is 8 centimeters, but I don't know these top 3 sides. But since I'm finding the perimeter of this figure, I do know what those 3 sides would add up to. Since the whole width of the figure is 8 centimeters, these 3 sides would have to add up to 8. So for the perimeter, I'm going to add an 8 plus another 8 for the bottom side, and then those 3 parts on the top put together. And I can kind of take a similar strategy with the height of the figure. These sides on the right side of the figure, 2 and 2, make the height of the figure 4 centimeters. So that means these sides over here will also have to add up to 4 centimeters. In this case, I can determine that this would actually be a 1, but I really just need to add the 2 4s. And adding those all together, we get a perimeter of 24 centimeters. In this next example, we'll use a similar strategy to find the perimeter. For the height of the figure, we have 16. That means this piece, this piece, this piece, and this piece will all add up to 16. So I'm going to add 2 16s. And for the width of the figure, the bottom is 18. I need to be careful here. This piece right here added to this piece on the top would add up to 18. But I actually have 2 extra sides that aren't accounted for. And if all angles in this figure are right angles, this would need to be a 5 as well. So I have to add in those 2 extra 5s in this case. So I'm going to add in 2 18s plus the 2 extra 5s. And we add them all together, and we get a perimeter of 78 units, whatever these units are. In this next example, we need to find the area and perimeter of an isosceles triangle. The problem is, when we find the area of a triangle, we need the base and the height. The perimeter is going to be easy in this one. Because it's isosceles, both of these sides are 13, and we add 13 plus 13 plus 24. We get 50. Whatever the units are. And the area is a little trickier. For the area, the problem is we don't know the height. To find the area of a triangle, remember that we have to do 1/2 base times height, or base times height divided by 2. And the base and height have to make a right angle. In this case, we don't have a right angle, so we have to draw a line from the top of the triangle straight down to the base at a right angle. And that would be the height of the triangle. Now, in an isosceles triangle, that line will go straight down to the midpoint of side BC, cutting that in half. So it gives us a little right triangle right here with a leg of 12. the hypotenuse of 13, and then we could use Pythagorean theorem to find the height. So using a squared plus b squared equals c squared, if this is my a, or we could just call it h, we get h squared plus 12 squared equals 13 squared. And if you know your Pythagorean triples, there's certain Pythagorean combinations that show up a lot. This is one of them. It's 5, 12, 13. So since we have a leg of 12 and a hypotenuse of 13, if we remember that, we would know that that height would have to be 5. And sorry, this triangle, the diagram is not really drawn to scale. But the height of this triangle H would have to be 5. Now to find the area of the triangle, I do 1/2 base times height. So 1/2, remember that the base of this triangle is the whole bottom side. So it's not going to be 12, it's going to be 24. And the height we found to be 5. And for the area of the triangle, that gives us 60 square units. In this next example, we have a rhombus that we're trying to find the area and perimeter of. But we can think of this rhombus as 4 little right triangles put together. The diagonals of a rhombus always meet at a right angle. So these are 4 little right triangles that are all congruent. So they have a short side of 2, a short leg of 2, a longer leg of 5, and we just need the hypotenuse. So using Pythagorean theorem, 2 squared plus 5 squared equals c squared. This is not one of my Pythagorean triples, so I keep going. That's 4 plus 25 equals c squared. 29 equals c squared, and c would be the square root of 29. I can't simplify that radical, so I just leave it, and I get the square root of 29 for the hypotenuse of that triangle. And since this is a rhombus with 4 equal sides, all of these outer sides would be the square root of 29. For the perimeter, I'm just adding up the outside sides, and I have 4 times the square root of 29, which is 4 square root of 29. Now the area of this figure, I can find the area of one of those little triangles and then just multiply it by 4 since they're 4 congruent triangles. So one of those little triangles has a short leg of 2, a longer leg of 5, and that would be the base and the height of the triangle since they make a right angle. So using 1/2 base times height, I get 1/2 times 2 times 5, which is 5. So the area of one of these little triangles is 5 square units. And if I want the area of the whole figure, there's 4 identical triangles. I just multiply 4 times 5, and we get 20 square units for the area of the entire figure.